Syracuse, a town defined by education, by culture, and by the people who populate its centers, cities, and neighborhoods. But on a more fundamental level, what describes Syracuse physically? What is the geologic identity of Syracuse, and how did it get here? On campus, one might find a wide variety of cobble, gravel, and other small pebbles that decorate the surrounding sidewalks and foot trails. Buildings are built from brick, a conglomerate typically derived from shale and clay. If any of these rocks around campus seem strange or oddly different or seem like they don't belong here, that's because they don't. These rocks are not supposed to be here. An igneous rock lying in front of your local gym could not have possibly found its way here on its own, given the lack of volcanic activity on the East Coast, and according to the United States Geological Survey, the rock foundation of New York, specifically Syracuse, is primarily dolomite, limestone, shale, and other evaporites. An igneous rock found lying about the East Coast is about as natural as a tacky pink flamingo outside Beverly Hills. If these rocks on campus tell a story of decor and human interference, then what story were the other rocks going to tell me? The Skytop Quarry, located near the south campus of Syracuse University, has been extensively mined for its rich limestone content, as the rock is often used as a key ingredient in industrial concrete. The excavation of the site has left precious few traces of the initial deposit, and the quarry now contains a collection of extremely brittle limestone, and is considered to be a delicate environment. Even the slightest movements were enough to cause serious fracture in some of the loose rocks atop the hill. The rock bed has also proven vulnerable to the forces of both man and nature, as local foot traffic and vehicle use within the area has given way to slippage and erosion. This influence is in addition to both the natural processes such as jointing, wedging, and weathering, as well as those natural to Syracuse, such as the frequent thunderstorms. After my first visit to Skytop's once rich limestone quarry, I discovered a new clue tucked away in the history of the American Northeast. Approximately 20,000 years ago, the Earth had been subject to the last glacial maximum, a great ice age that left many areas of the northeastern United States covered in a thick glacier called the Laurentide Ice Sheet. As the Laurentide melted over a period of nearly 70,000 years, it scattered many dense deposits of mineral-rich till containing calcium carbonate, a key mineral in the formation of limestone, around the state of New York. In the case of New York's limestone quarries, the deposits formed when calcium carbonate precipitated from water and mixed with other sediments to form the chemical sedimentary rock limestone. As I concluded my sweep of SU and its surrounding grounds near South Campus, I realized I had to go further, and my travels eventually took me to the Green Lakes National State Park. Green Lakes was formed by the melting of a glacier that eroded the surrounding area and essentially created a landfill for the remaining melts as mineral-rich water filled the eroded area. This melted ice deposited an abundance of calcium carbonate in addition to the carbon remains of small organisms formed lake. These deposits from the Laurentide Ice Sheet, called till, define almost every factor of the lake. The apparent color of the water is due to a combination of factors such as light absorption, deep, clear water in the presence of calcium carbonate. All these factors contributed to the modern Green Lakes teal-tinged waters. As discovered by scientists investigating the site prior to my discoveries, the process first begins when light penetrates the water. The red end of the color spectrum, or the longer wavelengths of light, are absorbed near the surface of the water. This allows the green and blue wavelengths to penetrate deeper below the surface. At the lower depths of the lake, estimated to be between 130 and 171 feet, the green and blue wavelengths are scattered and reflected to the surface where they are visible to the human eye spectrum as a bluish-green color. This process is only possible due to the high presence of calcium carbonate, as this mineral removes the filtering effect of other dissolved organic minerals. This process leaves behind a very peculiar byproduct: coral reefs. If one were to think they had to leave for the tropics to find coral reefs, they would surely be mistaken. Forming near the shallow areas of the lake, limestone accumulates into calcium carbonate-based coral deposits that play host to a wide variety of algae, smaller fish, and other microorganisms present in the lake, while the remaining sediment accumulates towards the bottom of the lake, where it forms a thick, murky fog of calcium too dense to remain in the shallows. Syracuse is not a town of brick and mortar so much as it is an environment of limestone. The passing of the Ice Age tens of thousands of years ago continues to maintain a presence in the legacy of the minerals left behind. This land is just as bound to the past as it is to the future, no matter how many cobbles are shipped in and shipped out. This has been Syracuse, a rockumentary.